All right, so the problem was constructed as follows. This is the XY axis. So we have a displacement of (18 meters). That's A. And then we have 25 meters. That's B. And the problem says, how far are you from the starting point? This is your starting point, and this is the final position. So this is effectively a displacement problem. Okay, displacement focuses on where you started and where you ended up. Distance doesn't look at the direction. Distance just adds up how much distance you actually covered. So based on what we know, according to Pythagoras theorem, we know that r squared equals a squared plus b squared, which means r equals square root of 18 meters squared plus 25 meters squared. Okay, and that is going to be 30.8 meters. Now the compass direction, again, if we consider this as the angle, 25 meters is opposite this angle, 18 meters is adjacent this angle. So the angle will be the inverse tangent of the opposite, which is 25, divided by the adjacent, which is 18 meters.
Good question.
Yes.
How is r equal to 30.8?
Say it again.
How is r equal to 30.8?
If you calculate the expression under the square root sign, you will get 30.8. Yes. So do 18 squared plus 25 squared, and then take the square root. You get 30.8.
Alrighty, I see it now. Thank you.
Okay. So the inverse tangent of this will give you 54.25 degrees. So, and that is this angle. Okay. So, how would you describe this angle?
It's 54.25 degrees north of west.
North of west. Okay. So this will be 54.25 degrees north of west, because this is your west. This is your west, and this is your north. So you're starting from west and then going north, 54.25 degrees. Okay.
Okay.
Okay. So you could if you wanted to describe it in terms of this angle, in terms of this angle, then you would say, this angle, you would say you will subtract this from 90 degrees, and that will give it 35.8 degrees west of north. Okay.
Okay.
So either one is correct. Any question?
No, that's been very helpful.
No. All right. No question. So let's proceed. The next problem is number 14.
Okay. Number 14.
Well, number 14, I'm going to skip number 14 because it's effectively the same as number 1 that we just did.
Okay.
Part A says find the total distance. Well, let's do it. So let's do it so that because this is a little bit more.
Find the following for path B in figure 3.5, the total distance traveled and the magnitude and direction of the displacement from start to finish. In this part of the problem, explicitly show how you follow the steps of analytical method of vector addition.
Okay. So, what are the analytical steps of vector addition? So the steps for vector addition, let's say you have a vector R, which is equal to 3 vectors A plus B plus C. Okay. So how do you go about adding these 3 vectors? According to the analytical method of vector addition, you will find the X and Y components. So step 1, find X, Y components of all vectors to be added. Okay. Step number 2, you're going to add X components so to get a resultant X, and then add Y components to get the resultant Y. Okay, so let me use the notation RY and RX to indicate the resultant in the X and Y direction. And let me use a different color. So RX and RY. So step number 3, you will find the resultant by doing this RX squared plus RY squared square root. So this is a summary of how you add vectors. Okay.
Huh?
Is this strange to you? Have you reviewed this while studying chapter 3?
I remember going through it. I do need to go back and review it though.
Okay. So
but no, it's not new.
Okay, so these are the steps. Okay, so again, to translate this into actual calculations, I'm going to still use the notation of A, B, C to represent 3 vectors. So if you're adding three vectors A, B, C to get R. So you say R sub X, that's the X component of the resultant, equals AX plus BX plus CX. R sub Y equals AY plus BY plus CY. Okay?
Okay.
So this is the mathematical form of what I just wrote on the previous slide. So you find the X component of A, B, C, add them up to get Rx. You find the Y component of A, B, and C, add them up to get Ry. And then your R is equal to, so the magnitude of R is equal to Rx squared plus Ry squared. And the direction will be the inverse tangent of Ry over Rx. Okay?
Okay.
So those are the three steps. So let's apply these steps to the problem given. So for part A says find the magnitude of the what? Or find the total distance. So again, that is straightforward. Okay, so the distance will be equal to what?
We just add them all up, correct?
Okay, so you have 2 blocks, 2 times 120 plus, you have 6 blocks, 6 times 120 plus, you have 4 blocks, and then you have 1 block. So this gives you a total of 1560 meters. Okay?
Huh?
That is the distance along the path labeled D in figure 3.58. Now part B, your Rx is going to be equal to the sum of the X components only. Okay?
Okay.
So for the first displacement, is there any X component involved?
A is only going in the Y direction.
Okay, we're looking at the path D. Okay, the path level D. So you go 2 blocks in the Y direction at first. So there is no X component in that displacement. Then next, you go how many blocks in the X direction?
6.
6 blocks. So plus 6 times 120. Okay, and you go in the positive X direction. So that's why we have this plus. Next, you go 4 blocks in which direction?
That's Y.
Okay, so no X displacement. That means the X component is 0. And then from there you go how many blocks?
1.
Which direction?
That's the X.
Positive or negative?
Negative. No,
Okay.
that's, yes, negative.
Negative. So you put minus 1 times 120. Okay. So that's your net X displacement. So 6 times 120 is 720. Minus 120 will give you 600. So 720 minus 120, which is 600 meters. Now let's look for Ry. Along the same path, level D. The first displacement is entirely in which direction?
X. So
Okay.
that's
Okay, so you don't have any
Hello.
hold on.
Okay, I was just making sure.
So 3.58. So the first displacement is how many blocks in the y direction?
2.
2 blocks, and that is the minus y direction, right?
Yes.
So minus 2 times 120. And then the next displacement is along x, which means there's no y displacement. And after that, we have a displacement of what? How many blocks?
4 in the positive direction.
So 4 times 120. And then we have x, which means no y. So minus 2 times 120 plus 4 times 120 will give us minus 240 plus 480, which is 240 meters. Okay?
Okay.
Okay.
So that's the step for the x and y components. And then your r, let me use a different color. Your r is equal to square root of rx squared plus ry squared. And so this is equal to square root of 600 squared plus 240 squared, which is 646. Okay, and then theta, I'm going to do the calculation here. I just want everything to fit into this one slide. So theta is equal to the inverse tangent of ry over rx. So that is, so tan inverse of 240 over 600, which is 21.8 degrees. Okay. Now, since Rx is positive and Ry is positive, take note. So this is positive, and let me use a different color. So this is positive, and this is positive. So that tells us the vector is located in the first quadrant. Okay.
Okay.
Yeah, because only in the first quadrant do we have positive x and positive y. Does that make sense?
Yes.
So a positive x component means the x component lies along this direction. So this is our rx, and then this is our ry, positive ry. So this angle that we found is 21.8 21.8 degrees north of east. Does that make sense?
Yes.
And we look at the diagram where the person ends up is actually north of east. So the resultant vector, the magnitude is 646 meters. The direction is 21.8 degrees north of east. Any questions?
No, not at this time.
Okay, so with this, you should be able to solve any other vector problem because this is like the more general problem in the okay, so numbers. So which problem did we just do? That's number 14.
That was 14.
Okay. So 16 is similar to I think we actually did 16 before. So we did number 16. Sixteen is similar to 4, if not identical, actually identical to 4. And then the next is 25. So 25 is projectile motion. So let's do this and then we'll run out our session with this last problem.
Okay.
Okay, Regina, can you go ahead and read the problem for us?
A projectile is launched at ground level with an initial speed of 50.0 meters per second at an angle of 30.0 degrees above the horizontal. It strikes a target above the ground 3.00 seconds later. What are the x and y distances from where the projectile was launched to where it lands?
Okay. So I believe, yeah, that's the problem. So now this is a problem in the family of free fall problems that we discussed earlier in chapter 2. The only difference is in chapter 2 we were concerned only with motion in one direction, in one dimension, that is either x or y. Now we have a situation where an object is launched with both x and y velocity. So that's the initial velocity, but because this velocity has an angle of 30 degrees, it's going to start out with 2 components, one in the x direction, one in the y direction. Okay?
Okay.
So you're looking for the distance traveled, the total distance traveled by the projectile is also called the range. Okay, range. You can denote it by R. So the problem says find what are the x and y distances from where the projectile was launched? So we know that the range of a projectile
Is that the A plus B plus C?
Say it again.
Is that the A plus B plus C?
No. The A plus B plus C in the previous problem was the resultant vector. This is a different thing. R here just means range.
Okay.
It's not resultant.
Okay.
Okay. So R is the displacement along the x direction. How far the projectile lands from the starting point. That's called the range.
Gotcha.
Okay. So in effect, we're looking for delta x, and the formula for the range of a projectile, we look from the equation section, is given as v naught squared sine of 2 theta divided by g. Okay. So this is 50 meters per second. We're going to square it. Sine of 2 times 30, which is 60 degrees, divided by 9.8 meters per second squared. And this will give you 221 meters.
221 meters.
Okay. Okay, to find the displacement in the x, that's the x distance and the y distance. Now, for this diagram, the diagram I drew here, delta x is the same as the range. But in some cases, let's say if the projectile landed somewhere here, okay, let's say there was a target here. If the projectile landed here, then even though the x distance is still from here to here, the range will actually be from here to there. Okay? Does that make sense?
Yeah.
Okay. I just wanted to point that out. So x may be different from the range in some cases if the projectile doesn't land on the same level from which it was launched. So like in this problem, to find the x component, you will say v naught x times t. Okay? That's one of the equations. Remember, for projectile motion, you have v o x equals constant because there is no acceleration in the x direction for projectile motion. We know that ay is equal to minus 9.8 meters per second squared. So we know that delta x is just equal to voxt. Delta y is equal to voyt plus 1/2 ayt squared. These are all equations for projectile or free fall. We also have Vy equals Voy plus Ayt. We also have Vy squared equals Voy squared plus 2Ay delta y. These are the equations for free fall. And Ay in all this equation is minus 9.8. So for this problem, delta x is Vox times t, which is Vox, the x component of this initial speed is, Vox will be equal to what? How would you find the x component of the speed?
That is cosine.
Okay. Okay, Vox is Vo cosine of theta, and Voy is
Voy.
Vo sine of theta, right?
Mm-hmm.
Because if this is your triangle, this is your opposite side. This is your adjacent side, and this is your hypotenuse. You know that opposite of a hypotenuse is sine, adjacent of a hypotenuse is cosine. So the opposite is equal to hypotenuse times the sine of the angle, and the adjacent is equal to the hypotenuse times the cosine.
Okay.
So your Voxt is just 50 meters per second, V naught, cosine of 30 degrees, then times the time, which is 3 seconds. And that will give you 1.3 times 10 to the 2 meters. I'm writing this way because of the significant figures. 1.30 times 10 to the 2 meters. We have to keep 3 significant figures. Now, delta y will be equal to Voy times t plus 1/2 Ay times t squared, which is that is equal to your 50 meters per second times the sine of 30 degrees times 3 seconds plus your 1/2 minus 9.8 meters per second squared, that's A times 3 squared. And that will give you 30.9 meters. Okay, so that means the projectile landed here, 30.9 meters, and your x was more than 30 meters, or 1.30 times 10 to the 2 meters. Okay.
Okay.
So that's the solution to number 25. So the projectile landed 130 meters horizontally and 30.9 meters vertically from the launching point. And if you find the resultant of those two, you will get 221. Okay. Any questions?
No, not on this one.
Okay. So that will conclude our study session tonight. Attempt problem 25. 6 and 27. Okay. 26 is similar vector free fall and vector components. 27 is also similar but slightly different. So attempt those ones, and we will have another study session next Tuesday to look at chapter 4 and probably the practice test also.
All righty. Thank you.
All right.
Thank you so much.
You're welcome. Bye-bye.
Bye.